Consider a population in which the smallest and largest scores are x equals to 8 and x equals to 16. Which of the following statements can be concluded? A. The population mean is somewhere between 8 and 16. B. The population standard deviation is smaller than 9. C. The population mean is between 8 and 16 and the standard deviation is less than 9. D. None of the above is true. To make sense of this, I'm going to go through these one option at a time. So let's consider A. The population mean is somewhere between 8 and 16. Does that make sense? Well, if my smallest and largest scores are 8 and 16, it certainly does make sense that the population mean would be somewhere between the smallest and the largest score. Think about it this way: if you have a group of people where the youngest person is 8 and the oldest person is 16, the average age is going to be somewhere between 8 and 16. The average age can't be more than the oldest person. It can't be less than the youngest person. So of course, the mean will fall somewhere between the lowest and the highest values. Now what about B? The population standard deviation is smaller than 9. This one is also true, but it's a little bit trickier. Let's think about what we just said in part A. We've concluded that the mean has to be somewhere between 8 and 16. So let's pretend that it is 8. I know that that's not exactly between 8 and 16, but it's just very close to one end. We'll also try being close to 16. If my mean is 8, then I have a score that is really far from 8. That score is 16. How far is it? How big is my biggest deviation? Well, if I have a score of 16 and the mean is 8, then I'm going to end up with a deviation, which is 16 minus 8. It's going to be 8. This will be the biggest possible deviation. Think of the other score, the other end of the spectrum. I have a score that's 8. 8 minus 8, my deviation will be 0. So the closer you get to 8, the smaller the deviations will be. The closer you get to the other end, the oldest kids, if I've got a group of kids between the ages of 8 and 16, the biggest difference between their age, a person's age, and the average, which is 8, is going to be this deviation here. So this is my largest possible deviation. What if the average was not 8? What if the average was instead 16? Well, then my extreme ages will look like this. The deviation of a person whose age is 16, how different is their age? How much does their age deviate from the average if the average is 16? It doesn't. It's the same. What about somebody who's 8 years old? Well, they deviate from the mean. They are 8 below. So my deviations at most could have a size of 8. So the population standard deviation has got to be somewhat smaller than 9. 9 is just a safe number here. All of the things that we considered were 8. These are extremes we were working with. Imagine somebody who had an age of 12. How close is the 12-year-old to a 16-year-old? They are 4 years younger. What if I had somebody who was 10 when the average is 8? They are 2 above. So you can see any other deviations aren't going to have numbers as large as 8. Certainly not 9. So the population mean will be somewhere between 8 and 16. The standard deviation as a result is going to be smaller than 9. C just adds the two of these together. It says the population mean is between 8 and 16 and the standard deviation is less than 9. So this is our answer.